about software and data support in OSG. And the first question that we have here is, why do we group these together, right? Why do we talk about this in one presentation instead of two? And it turns out that that software and data, many of the kind of methods and how we deal with getting things to that job sandbox is very similar for software and data, and we end up using the same tooling and mechanisms in some cases at least to handle both of them. And the other things that we already talked about here in the chat a little bit is that both software and data, the complexity of those, there's many dimensions and many different complexities, right? So, and therefore we don't have one solution that just fits across everything, right? We have very simple software pieces up to kind of full, people that need full, almost operating systems. Similar with data, we have users that runs with very small amounts of data in number of files and in data sizes, up to some really, really big ones, right? And we need different tools for those different use cases. So in this presentation, I'm going to talk a little bit about software first and the different options available there, and then similar with data. And also, again, these are the kind of the presented or preferred methods. There are others, but this is a great starting point for most users. So let's start with the software part. And so the first mechanism that we're going to talk about, and this is the one that Jess was mentioning and that we talked about in the chat, is the conjure file transfer mechanism. And so for software, if you just specify an executable, and that executable, best case, that executable is self-contained, right? That means that it has no external dynamic library dependencies or no assumptions about where things are in the file systems. If you have that executable, you can just ship it with the job and everything just works. The executable goes, lands in the sandbox, executes, and everything is good. And there are some variations of this that are also kind of common in our world. One is the second one I have here. Let me do a pointer, which is this one over here. And in this case, we have a user that wants to run Python with a set of special Python modules. And we have a recipe in our documentation on how to create this virtual env and ship it with the job. So only the kind of special pieces that this user needs goes with the job. And surprise, surprise, we're talking about software, but we are transferring it as an input file, right? So here's the crossover between software and data a little bit. And you can also do this, for example, if you have a binary with maybe just one or two dynamic building libraries, that you can ship them with the job as well, and just tell the binary to find them in the current working directory, and that will work as well. So the advantages here are this is really simple to use. So number one thing to try. A second methods of getting software to our jobs is with modules. And if you have been on a campus cluster or an Exceed machine or more HPC, this is a very common way of getting software to users. And the idea here is that we have a catalog of commonly used tools that we have installed and that we have to configure the environment for. And then you use this tool, the module tool, to load it into your environment. And this works great if you have, again, a common tool that more than one user is using. Then we can install it once and kind of reuse that tool. So in this case here, we have a job and that it has to run on a modules machine. And in this job wrapper here, it module loads both type 2. I think there was a way to, there we go, and then runs that tool. Where this is less useful is if you have software that is unique to your workload. because we probably will not install it in modules for just one user. Or if you have very specific kind of version requirements or how that software was like needed to be compiled, we might not, do that work in that case. And there's a better way of doing that in the next couple of slides. So that's one, modules. And before I go on, I want to mention this CVFMS, and this is also how we distribute modules. This is how we distribute other pieces of software and data. So what do you need to know about CVFMS? Because this does keep coming back into documentation, for example, is that it's a globally distributed file system, and it's read-only. So when you land on these nodes, or even on the head nodes, you'll find /CVFMS directory, and there's a bunch of different subdirectories in there with different things, software and data from different projects. And so this is a very convenient way for us to publish data or software in one place and then use it wherever we land. And so CVFMS, well, that's how we do modules, right? We land on any of these compute nodes. When you do the module load command, well, they load it from CVFMS somewhere. But it's also something that enables us to do containers well on OSG. And so containers, well, it's just like they are Docker containers. They're executed in Singularity, but they are what do you think about a Docker container. And so these are full images, right? They're full operating system images with your software or with your configuration already baked into it. And this is a great solution if you have more complex software stacks, right? You can see, for example, here, TensorFlow is a common one that's really difficult to install. But with a container, you can just load a container and you have the TensorFlow environment. And running containers is also something that's really baked into the OSG ecosystem or infrastructure. So if you want to run a container in your submit file, well, you need to say, I'm going to land on a Singularity machine, and then just to specify that image. And again, CVFMS coming back here, right? So this allows us to be able to provide consistent environments or custom environments. Some of these container motivations. So I talked about consistent environment. You can have the same exact environment wherever you land, instead of have a slightly different one wherever site provides that resource. And it allows you to do the custom software environments. And it also has a limit of GPUs. For example, if you are big GPU users, you'll be able to bring that environment. It's really, really useful. I don't see everything in the chat. Let me know if I need to stop and talk about something.
Yeah, are you switching over to data next, Mats?
I am.
Okay, so let's pause and talk about software.
All right.
Yeah,
so there were some questions.
Since there was a pause, I want to point out, and obviously depending on the size of the container, that you can ship the container with your job from your access point. So I want to make sure that the message is not that the only way to use containers is via this method.
Okay.
Thanks, Ron. So I think there were some questions about modules, Mats, including like who sets them up.
I'm trying to catch up.
Yeah, there's a lot of chatter.
Yeah. All right, so clarify how modules work. Right. A local admin does not control them. No, they're all part of OSG. So just like you would do on your campus cluster, right? Like on the head node or on the access point, whatever you see on there, like you do the module load or the module avail and module spider, those commands will show you the catalog. And when your job lands on a compute node somewhere, that's exactly the same catalog available to that job. So we have defined this once and it's the same everywhere. Right, the modules are maintained by OSG. Nodes, okay, and that's responded to. And anything else I need to address before moving on?
I think we're good. I'm going to answer
All
a
right.
question that just came in about where the OSG available modules are on the system. Are they system wide, et cetera? So
Okay, all right, yeah. All right, so I'll move on to data then. And so here's a picture of what you kind of need to know for doing data management on OSG Connect. And what you need to know first, there's two different file systems that you need to be aware of. And these are here on the left, where we have the home file system. That's a home directory that we all use too. And there's also a /public /username directory. And these are used slightly different. And again, this is a recommended way of interacting with this file systems. So we're going to walk through each one of those mechanisms here in a second. But keep those two file systems in mind. Like the home directory is obviously private to the user. The /public, as the name implies, is a public file system. And the first method, again, this is probably the fourth time we're talking about counter file transfers. The table here is directly from our documentation, so you can find this on the website. So here's the recommended. Like if you have less than 100 megabytes or 500 megabytes total for the job, HG counter file transfer is the recommended way. You use the transfer input files equal to, and then a list of those files. We did talk or mention at least the transfer output files. That is a keyword that you can use if you want to be explicit about what files that you want to get back. However, if you don't have to, it's better to just leave it undefined, and Condor will just transfer back the files that are created. Now, when you do that, remember, you need to have unique files, right? They have to be named so that two jobs are not generating the same file, because they will just be overwritten when that data comes back. The rest of these mechanisms I'm going to talk about depends on this /public. And when we talk about this, it's really just a building block, because there are multiple ways of accessing this, right? So if you are on our access point nodes and you look in public, you will just see a large file system. It looks like a regular file system that's available on those nodes. The way that we want to use this is for the staging of big data sets. So run the jobs from /home and then do this data staging from /public. What you need to know about this, though, is that it is a public file system. So data that you put on here, it is public, and it goes on HTTP, and it goes on CVFMS, and so it really needs to be, users need to be aware of this, so they don't put, for example, sensitive data on here. And then there's multiple access methods, including that it gets directly synced to CVFMS. So you can also just look at CVFMS to access that data from the compute nodes. One way of pulling data to and from public to the compute node, is via HTTP. And what's different from this example to the previous one is that, again, we're using transfer input files on here, but now we have a URL, right? We have a URL that goes to OSG Connect /public, and then maps into that file system. And the advantages here is that we can pull a little bit bigger files than we could in the Condor case, in the Condor IO case. But a side effect of doing this is also that this file can be cached on the compute nodes or close to compute nodes. And this makes this a very efficient way of doing, if you have data reuse in your jobs, if you have jobs that are using the same files over and over again, that caching can be really, really beneficial, because you don't have to pull a fresh copy every time. Another way to access /public is via stash cache. And again, this is from the documentation where we see there's a new line in here and it says over 1 gigabyte, less than 10 gigabytes per job. And these are just guidelines. You know, if you're at 11, it would still work. And what's the advantage with Stash Cache or Stash CP is that this is a tool that's specifically built for extreme caching, right? So anything that you used when you are pulling with Stash CP is that will be cached at multiple levels. And again, if you have jobs that are reusing the data over and over again, now you have that automatically built into your data fetching. When you move up to Stash Cache, you need to kind of use job wrappers for it and do the data staging inside the wrapper here. We are working on making this a little bit better in Condors. You could just use URL there as well, but it's not fully functional. And so in this case, we do module load, Stash Cache, tying all the way back to using modules and software again. And we do, in this case, we want to fetch a file, so we do Stash CP, the source and destination. We run our computation. And another thing that's obviously optional, but the really neat about Stash Cache is that we can be used in both directions. So not only can we fetch our data with Stash Cache, we can also write it back into public directly. And this, a lot of users don't need this. They don't generate that big of the outputs per job. But if you have this use case, know that Stash Cache can write back. And it's also transparently done because there's a credential that goes with all the jobs that enables this data transfer to authenticate. So that's everything. And I'll go to questions. I see there are more questions in the chat again. Pre-staging data, correct. So the idea is that for pre-staging data, Stash Cache grid FTP. I don't know about details on that. Alistair, if you expand on that question, I'll answer that one. Bennett says with Stash Cache, the cache data is available near the cache locations. Yes. So I probably have a slide on that actually somewhere. So the other thing that Stash does is that it can select different methods. And that's all, again, transparent to user. You just do the Stash CP command. But when you do that, it can select different methods based on where it can find a copy close to that compute node. So it can pull from CVFMS, it can pull with HTTP, it can pull via XRootD, I think. So there's multiple ways that job can fetch that piece of data, and that's all done with geolocation and having multiple copies in multiple protocols.
Yep. So the user doesn't have to be aware of that.
Right.
In their job, they run a Stash CP command referencing sort of an absolute location of their files relative to how they staged it from an OSG Connect access point, or it could be a local campus access point with its own data origin. And then behind the scenes, the Stash CP framework makes decisions about which protocol to use to get that data to the job.
Right. Any software questions I didn't answer, Lauren?
No, I think we're good on software, and I've moved the answers from the chat into the notes document for today as well. Somebody else just asked, how long do I need to wait for data in /public to be available to compute nodes?
So it's instantaneous when it comes to, for example, Stash CP and HTTP, all that stuff is instantaneous. And that's the nice thing about Stash CP, right? It will determine if it's in CVFMS, right, already. And that, the syncing here that I mentioned on this side here, that data is synced to this location, that could probably take an hour or so, right? The other thing that to be aware of when you're doing, especially Stash CP, if you use this here, like let's say that this is the URL that I used in one workload I submitted, and now I have an updated data1.csv that I want to use. If I put that in the same location, if I just overwrite this file, like the way the stash cache is so heavily cached that it might not propagate. So you have to use unique locations for unique file names, unique locations. Once you have provided a copy to stash cache, it might never expire.
To pick up on your question, Alistair, so we don't recommend grid FTP for like users. That's usually for like big projects with lots of staff. So stash cache is the way to go. And the idea is that you upload your data to this public space, and then the stash CP copy tool that Mats has here on the slide it will get the data somehow. You don't have to know where the data is or how much it's cached or anything. Stash CP will get the data somehow. There's just different things happening behind the scenes in the OSG infrastructure to make accessing that data more efficient. But from your perspective, the data goes into public, and we do this for larger data because we care more about efficiency the bigger the data is, and then you distribute. And then you can just access it, and we worry about how the data is being cached or not or distributed behind the scenes, if that helps answer that question.
Yeah, and do you track the software? Well, we do track containers, like what containers are used and how much they are used. At least we used to do modules. I actually think that's maybe not current, but somewhat. However, if you use your own container or your own, you ship the data with, or you ship the software with the job. No, we do not track that.
There was one more question about Singularity containers without Docker.
Yeah, it's been on a to-do list for a long time. I think technically we can do it, but we haven't actually made it part of the workflow yet.
Yeah, so Condor and the OSG environment, like Marone said, can manage containers in ways other than what we currently do, where a Docker container is submitted and we whitelist it so that it can be cached through CVFMS and run through Singularity locally on the exec node. But that's, like I said, just one way. And it's the way right now that we've got formalized so that it's a simple enough process for the user to submit their container in a consistent way that we can support.
Right. And the problem here is actually not the format, but the problem is that Singularity doesn't really have a great repository of images. So we can't even detect changes and kind of do this automatic synchronization that we can. That's very easy with Docker Hub. So I'll if you're interested, contact me and I'll point you to a GitHub issue where we're tracking this thing, and we'll hopefully get it in there at some point.
All right. Thanks, everybody.